In this section, we're taking a look at beginning of transformations. We're looking at 3 transformations. In part 1, we're going to take a look at reflections and rotations. And then part 2, we're going to take a look at how transformations apply. So in part 1, we're looking for, the first part was reflections of a point. So we have a point here at 2 comma 4. So I'm going to go ahead and write out that point 2 comma 4 so I know exactly what I'm dealing with. So 2 and 4. And in question 1, it says trace the graph above onto an overhead sheet or pad paper. Again, I can't do that on the computer, so just going to bear with me here. We're going to reflect the point A over the x-axis. So again, this is our x-axis right here. And there's our y-axis. To create the point A prime. And prime is the image. This is what's called the pre-image, is what we began with. An image is what we end up with. We're going to write the coordinates of A prime as an ordered pair. So I'm going to start here. I'm going to do this one in green. So question number 1 we'll do in green. We're going to take that and reflect it over the x-axis. So basically what's going to happen is we're going to take this point and we're just going to kind of bring it down. It doesn't change the left or right, it just changes the vertical coordinate. So when I reflect this over the x-axis, what's going to end up happening is I'm going to be right here at that point, and I call that A prime based on what the directions say. Write our coordinates of A prime as an ordered pair, and that would be 2 and negative 4. Notice that our x coordinate didn't change, but our y definitely did. Question 2 says reflect A over the y-axis, so there's our y-axis there, to create the point A double prime. Write the coordinates of A double prime as an ordered pair. So let's do this here. All right, so when I reflect over the y-axis, it's kind of the same idea as the x, but obviously in a different direction. So what's going to end up happening is this point's going to kind of get moved over here, same distance away from the y-axis. Our y-coordinate in this case doesn't change, but our x-coordinate certainly does. Again, I'm going to call that A double prime, and the coordinates of that are at negative 2 and 4. And then the third part says reflect A. So again, that's at our original point that we had. We're going to reflect that over the origin. The origin is this point down here, 0, 0. So that's the origin. So essentially what's going to happen is if we kind of line this up, we're going to basically kind of move this along a line here. And it's going to reflect over the origin to give us down to this point here. So the coordinate of that point is at negative 2 and negative 4. So now what we want to do is take a look at what are our conclusions based on what we see when we reflect over, the x-axis, the y-axis, the origin. What do we notice happens? So the x-axis, it looks like we took our original coordinate and the x-coordinate stayed the same, but the y-coordinate kind of stayed the same, but changed signs. So when I reflect over the y-axis, my conclusion is going to be that the y-coordinate, if I write this a little better, all right, y-coordinates, that's better, changes signs. X-coordinate doesn't change, the y-coordinate does. Part B says when we reflect over the y-axis, what happens? Well, we had negative 2 comma 4, so again, our original point was positive 2 comma 4, so it looks like our x-coordinate changed signs. And then part C, we want the origin. And for the origin, our original point, again, 2, 4, turns into negative 2, negative 4. Both of our coordinates change signs. Oops. Change signs. There we go. And that always happens when we reflect over either the x-axis, the y-axis, or the origin. These are steadfast rules that will always happen. Segments, they're basically the same thing. We're going to treat segments as 2 points. So here in segment AB, we have 2 points at negative 3, 5, and B is at 3, 1. So when we reflect out over the x-axis, again, our conclusion there was that the y-coordinate will change, so that would take us to 3, -1, so that would be b prime. And if I reflect a over the x-axis, I'm going to get -3, -5. And then that would be our reflection. So again, same idea here with segments as our coordinates. It's really no different, just more points to consider. So that's reflections. Now let's take a look at rotations and what happens with a rotation. So same idea, if we had the patty paper in front of us, we would use this, but obviously on a computer I can't do that. But we have the point here 2, 4, same one that we had before. And now what we're going to do is we're going to rotate this point A 90 degrees in the clockwise direction around this point here, which again is the origin 0, 0. So when I do that, if I rotate it 90 degrees, I'm basically going to turn this whole coordinate plane 90 degrees. And when I do that, my point will end up here. So we have A prime is at 4, -2. Question 2 says, do the same thing, but now rotate 180 degrees. So again, a little bit different rotation. Grab a good pen. There's a good pen. All right, so we're going to take the same point. Instead of rotating 90, we're going to keep going with that. So if we keep that circle going, we're going to end up right here. And that point is at -2 and -4. So again, we did change our coordinates. We changed the location. And it makes sense that if we go 90-degree rotation, we're going one quadrant down, because each of these right here are 90-degree measurements. So if we're going this way, we would expect a change in the quadrants. If we go 180, we expect a change in 2 quadrants. Question 3 says we are going to take our point A, and we're going to rotate it 270 degrees clockwise. You might be thinking, well, there's a quicker, easier way to do this. There actually is. Instead of rotating 270 degrees clockwise, we could do the same thing by going 90 degrees counterclockwise. Again, all the degrees in a circle add up to 360. We end up in the same spot. So if we do that, we do the 270 or the 90 counterclockwise. Let's do the 90 counterclockwise because it's easier. We're going to rotate this way. And when we do that, we're going to end up at this point right here. So again, you notice that something has changed about these coordinates. They're not exactly like they were before. When we did the reflection, they just changed signs. That's all that happened. But when we do the rotation, there's a flip-flop going on. So if we look at A, the x and the y coordinate switched places. If we look at A triple prime, the x and the y switch places again. All right, so we have that relationship going on. So we want to know what happens to the coordinates when we rotate 180 degrees. And this is one that's a unique exception because coordinates don't really switch. Technically, they switch twice, so they're back to the original. So if we started with A and went to A prime, there's a switch of x and y, and then to A double prime, there's a switch back. Well, what ends up happening is we have 180 degrees clockwise rotation, or counterclockwise in this case. We end up having the same x coordinates and the same y coordinates, but they have a different sign. So when that happens, we're going to change the sign of both coordinates. You might be thinking, well, wasn't that a reflection over the origin? That's exactly what it is. So in this case, a rotation of 180 degrees ends up being the same exact thing as a reflection over the origin. That will always happen when you're dealing with a 180-degree rotation. It's a reflection over the origin if you're rotating about that point 0, 0. All right, so the 90 degrees clockwise, this is the one we switch here to get A prime. So in this case, A prime, what we did is we took the x and y coordinates switched, And here's where we have to be very careful because we don't want to make the conclusion, oh, well, the y-coordinate changed sign. Kind of, but not really. If we had started here and went in this direction, actually the x-coordinate now becomes negative. So what ends up happening is the x and y-coordinates switch, and 1 changes signs. And we're not going to set up any steadfast rules for that because there are so many different combinations we can have. We're going to get into a problem with memorization and not really understanding of what a rotation actually is. And then for the 270 clockwise, we're doing the same basic thing. We're looking at our coordinates here for a triple prime. Again, the x and the y switched, and then one of those, in this case the x, changed sign. So x and y coordinates switched, and 1 changes signs. Again, it's best if we have the graph the point, we do the rotation, we can see which one changes. We don't want to start thinking, well, if it's in the quadrant 1, that's just a waste of time. It's better to graph and take a look at how this proceeds. And that's it for rotations and, reflections and rotations. In part 2, we're going to take a look at